Once again, welcome to the Berkeley Bitcoin Meetup. We host these pretty regularly. Please follow our meetup page if you are not currently. And today we have a very special guest, Sunny Aggarwal. He is actually a good friend of mine. We've done a lot of things together. He helped me a lot when I was running our libertarian club at Cal. He was our activism chair during the election cycle. And he actually convinced me to start a pirate party at Cal. So we ran for Senate at Cal and we got a seat, which is awesome. And then he dropped out of school and is now doing stuff with Tendermint. So please welcome Sunny.
Thank you. Hey everyone, I'm Sunny, and I'll be talking to you guys a bit about the project that I work on, which is Tendermint Cosmos. And it's really cool because Jay's also here in the back, and he's like the founder of it, so he can also answer questions if you have any. Yeah, so I guess a bit about me is, I helped start the transition from Bitcoin Association to blockchain at Berkeley. Back when it was like 7 people, and I helped create the decal that's here at Berkeley. I've previously worked at Consensus on a lot of their developer academy stuff, as well as Ethereum ontology stuff. And currently I'm a researcher with Tendermint, and I kind of joined Tendermint because I was interested in 2 things, which was proof of stake and blockchain interoperability. And it just so happens that that's perfect because that's basically the 2 things that Tendermint Cosmos does. Tendermint is sort of on the proof of stake side of things, while Cosmos is on the blockchain interoperability side of things. And so today I'll basically be talking to you about how these 2 linked, extremely related projects work together to create an internet of blockchains and solve many of the problems facing us right now in the blockchain space. So at the beginning, I'll start off with talking a little bit about the Tendermint architecture and how it differs from most of the other architectures that are available. So what we have here is basically what I'll call the simplified architecture. This is what's used in most blockchains, especially in the pre-Ethereum days. Basically, a blockchain has 3 main layers, in my opinion. You have the application layer, the consensus layer, and the networking layer, or the P2P layer. And what Bitcoin does, and most things that are offshoots of Bitcoin, is takes this entire software stack and bundles everything together as one piece. It's not very modular at all. And so that means if you want to update something and change things around, you basically have to fork their entire code base and start playing with stuff, which is really just not fun. So, that's what Ethereum kind of came along and said was there's probably a better way to do this and make it easier for people to build blockchain applications. And so what Ethereum did was it said, hey, we'll make the application layer and we'll still use the same bundle, but what you can do with your application is build your dApps as smart contracts on top of our application, which is the EVM. And this works pretty well. It made it very easy for people to build their own blockchain, build their own applications and stuff. But the issue here is, it still comes together as this one package that you can't really modify and have any control over. And so that's where Tendermint Core comes in. Tendermint Core is a piece of software that basically handles the bottom 2 layers. It handles the consensus and networking. And it basically lets you build any application you want as any arbitrary state machine on top. So before I go into the kind of applications you can build on top of Tendermint Core, let's talk a little bit about the bottom 2 layers first, specifically the consensus layer. Why Tendermint Core? So, it's based off of Tendermint Consensus, which is basically it's a BFT-based, consistent proof of stake algorithm. And basically, what that means by consistent is, unlike Bitcoin or many other, most blockchain Nakamoto consensus-based chains, instead of basically you get probabilistic finality, where over time you'll kind of figure out which chain is the longest one. While Tendermint, you kind of get because it's proof of stake, it's much faster, and you also get no forks. So once you see a transaction in a block, you know that block is finalized and that transaction is finalized. And so the cool thing about Tendermint is it can be adapted very easily to both public systems and private systems. Public systems will use it as proof of stake. Private systems will use it as proof of authority. But you still get the Byzantine fault-tolerant advantages, even though it's a permissioned system, which is like something that you don't get with like things like Raft. You get the instant finality. It's highly scalable. It works in asynchronous environments. So in proof of work, if there's high network throughput because let's say China has a giant firewall, high network latencies, you're basically never going to have finality because if your network latencies are higher than block times, the system can never come to consensus on what the proper block is. And so what Tendermint does is it actually adapts so it will always be safe in asynchrony and live in weak synchrony. If anyone wants to talk about the technical BFT stuff afterwards, feel free. I can talk about that. But also, Tendermint is also like, it's the basis for a lot of the other proof of stake systems, such as Casper. Right. So back to Tendermint ABCI. So I mean, that was kind of why this consensus software is really good. So what's the ABCI, right? ABCI is the interface that we've designed that allows you to write any arbitrary application that can talk to the Tendermint core engine. And so you can write your application in any language you want. We have we have the frameworks designed already for you to write your applications in like over 12 different languages already. And so, for example, you can take an existing VM such as Chain.com's VM, and this is something that someone created for our hackathon. They took Chain.com's VM, which was originally designed for a permission setting, just slapped it on top of Tendermint core, and now we have a permissionless, like a Tendermint version of Chain.com's VM. You can take other existing platforms, like if anyone wants, like it would be super cool to have Zcash on Tendermint. One of the things that we did was we took Ethereum's VM and slapped it on top of Tendermint consensus, and we call this Ethermint. And this is basically this is really cool because we basically have a fully proof of stake Ethereum. Like it can get like up to 1 to 3 second block times with hundreds of transactions per second, and it's an existing proof of stake Ethereum basically. And you can all your app dApps that you already wrote in Solidity for Ethereum can easily be adapted for Ethermint. And then one of the things that we realize is, it's not everyone has the time to go ahead and make their own VM from scratch, like making a Chain.com VM or something like that. So what we do is we created a framework called Cosmos SDK, where what we do is we give you a base VM called Basecoin. And what you can do with that is you can add plugins into the functionality of your blockchain, and then once you have all the functionality, you deploy it. And the cool thing about this is you get far more control over the functionality of the VM. Instead of like in an EVM where you're building on top of the application, with the Cosmos SDK, your plugins are actually building sort of into an application, and then you can change the functionality of the application at the base layer. And so what you can do is whatever application you want, you deploy it on its own blockchain, building on the Cosmos SDK. And so, one of the coolest things that we can do now, that if we have a lot of these chains all running Tendermint consensus, is we can hook them all up together and allow them to communicate with each other. And so any chain that's running on the Tendermint core software, it has the ability to use a protocol called IBC, which is basically a way for any two Tendermint chains to talk to each other. So that means you can have Chain.com, like Chainmint, talking to Ethermint, talking to Omis Go, who's building on Cosmos SDK, or talking to a private chain on Tendermint core. And these chains can all like send data amongst each other and send tokens amongst each other, and maybe even in the future do smart contract calls across chains. And it's not only limited actually to Tendermint core. IBC is natively designed in the current state for Tendermint core, but it can actually be adapted pretty easily for any finality focusing consensus algorithm so that includes Casper when Ethereum switches to that. And so one cool thing is that the ABCI interface can also be adapted to support different consensus algorithms as well. So, for example, Casper, correct by construction Casper, Vlad's Casper, probably it doesn't work very similarly to Vitalik's Casper, because Vitalik's Casper has to be, it can be done in the EVM, while Vlad's Casper kind of can't. And so it needs to be done at the client level. And so if they can build Vlad's Casper in as a Tendermint, as sort of Casper core, then you can build any applications on top of it and still follow the ABCI interface. And then you can use peg zones as well. So what if you have a chain that's doesn't have instant finality, or doesn't have finality at any point, such as Ethereum, right? Current Ethereum, proof of work never gets finality. It's always probabilistic. There's always a chance that a fork can suddenly appear and become the longest chain. So what we'll just do is, if you want to connect a non-finalized chain to this system, you just have to define some sort of pseudo-finality. So let's say in Ethereum we say a block that's 100 deep, it's good enough. Like, we're going to assume it's pseudo-finalized. And so what you can do is you can create a Tendermint chain and basically the function of this chain is to act as it comes to consensus on the 100th deepest block in the Ethereum chain. And basically it acts as a Tendermint chain that's a mirror of what's going on in the Ethereum chain. And then and then what you have to do is you have to define a new communication protocol. The one that we have is called ET-Gate. It was created by one of our hackathon contestants, a 17-year-old, which is super cool. But yeah, so basically ET-Gate is a way for a Tendermint peg zone chain to talk to a smart contract on Ethereum. And so you can now Ethereum will be able to interoperate with everything else in the Cosmos ecosystem. And these similar kind of protocols can be done with many more. Like, we can have a Bitcoin communication protocol peg zone, and we can have all these different peg zones. So one misconception often cited that's just not true is Cosmos is not limited to just Tendermint chains. There are ways to make it expand beyond just that. And so, okay, great. We can get this Internet of Chains. What is the benefit of this, right? And so I've been auditing a class at Berkeley called CS168, which is called Internet Architecture. And this was from one of the first lectures. It was the 5 goals of the Internet. And I realized that, wow, these are pretty similar goals to what we have for the blockchain ecosystem as well. And so what I did here was, let's see how an internet of blockchains helps accomplish the goals that the blockchain space is facing right now. So right off the bat, the most common one that everyone's worried about right now is scalability, right? And so there's 2 kinds of scalability. There's vertical scalability and horizontal scalability. Vertical scalability is all about how many transactions one chain can handle. So, maybe this can be solved through things like, in the Bitcoin world, increasing the block size. You can solve it with proof of stake, state channels, some really cutting edge stuff like recursive snarks. But it's all about how much one chain can do, and there will be some limit to this. I don't think we've reached it anywhere close to it yet. But maybe it'll be 100,000 transactions per second or 1 million transactions per second. But once we want to go past that, the next thing that we have to do is turn to something called horizontal scalability, which is getting many chains to work together. If your vertical throughput is X and you want 10X, how do you do that? The easiest way is just to have 10 chains and have them all talk to each other and be able to interoperate with each other. And so Tendermint, Cosmos do both vertical and horizontal scalability. On the vertical scalability side, it deals through Tendermint consensus and proof of stake. And Tendermint consensus has been shown to get over thousands of transactions per second using, this is sort of like a dummy application, but the throughput is really limited by whatever the computational complexity of your application is. And this is with 64 validators across 5 different continents. And we're doing a lot of research on how to make this even faster. But On the horizontal scalability side, we deal with this through the many chains talking to each other. Just like, this is kind of the basis for sharding, and these are all the same thing, really. These are all just different sharding techniques. But the question is, how do you shard your ecosystem? And I'll make the claim that application layer sharding, application-based sharding, is the most logical type of sharding. Because if you have many chains talking to you and they can all interoperate with each other, the bottleneck in your throughput is how much is going through the interoperation part. And so if you're sharding by address space, for example, like there's a EIP on Ethereum that like all the addresses that start with 0 are in one shard, all the ones that start with 1 are in another shard, 2 in another shard. But the problem with this is that there's a lot of interchain communication, which slows it down. The cool thing about sharding by application, where each application is in its own blockchain, is that usually transactions aren't happening. Most transactions for an application stay within that application. They're not actually going to other applications. And then very few transactions in an application go to other applications. And so that's a very logical way of sharding this ecosystem. And the cool thing about this is, you only have to be a full node for the applications you care about. So what I mean by that is, let's say you're a user of Golem, right? Why do you care about like processing all the storage A transactions or the Ether Delta transactions, or like there's so many transactions for applications that you just couldn't care about. You should only have to process and be a node for the applications you care about, and that allows for those applications to scale much better. Actually, I don't think it's dead. It's still there. I have a charger.
Weird.
I got it.
Yeah.
All right. Sorry about that, guys. All right. Where was I? All right. Yeah. So yeah, you only have to be a full node for the applications that you care about, and so that requires you to process much fewer types of transactions, which allows each node to process a lot more transactions, increasing the throughput of any individual application. On top of that, we want a lot of diversity, right? It doesn't make sense for all applications to be building on the same platform, because that creates a very anti-fragile system. You get all bugs that happen in the application layer are kind of pushed across every system. And so the cool thing with the Cosmos SDK and Tendermint ABCI is you can write your application in all sorts of different languages. These are just a couple of them. There's a few more that are not listed here. I know we have one in Haskell and C as well. And then you can connect your existing platforms like in Ethereum and Chain to the ABCI, as well as the peg zones. And so now I'm going to make a relatively radical and unpopular opinion where I think Turing-complete blockchains were a big mistake, and I do not like them at all. I think Turing-complete blockchains have some use cases, but I think in the general, I think smart contracts are meant to be used exactly as that. contracts. It doesn't make sense to build applications as smart contracts. If you're going to build an application, you should probably build it on, like I said, if we want application layer sharding, then if your blockchain has only your application on it, you should build your application's logic into the chain rather than putting it on top as a smart contract on top of the EVM. And this you can get a lot of flexibility through this as well, because, okay, I'll give you an example, walk through it. Let's say I'm building Golem, right? What do I really need to build Golem? It's basically, I'd say, two main components. You need a marketplace for buying and selling computation, and then you need some sort of verification system. So what I'll do is I'll take Basecoin, pull in two plugins. One is a marketplace plugin, and then a TrueBit plugin. I'll just put those two applications on the chain and deploy it. I don't want anyone to be able to add arbitrary code on top of my system. And let's say a few years down the road, I want to update it. Let's say ZK snarks become a thing, right? And I want ZK snark verification instead of TrueBit. Through governance, I can just hard fork and pull in the ZK snark verification plugin, and you can update your chain through governance, basically. And the benefits of not having these Turing-complete systems, I'd say there's three main benefits. One, you heavily reduce your attack surface, right? Do you really want people writing arbitrary code on your platform? Also, like an on-chain VM gives a lot of weird bugs that, like, created the DAO bug, the multiple parity bugs now. You also get a lot of efficiency gains, right? The EVM is a fully Turing-complete VM, but let's say you wanted to make a very simple application. You wanted to make a key value store. You're making Namecoin, right? You don't need a Turing-complete VM. That's just massive overhead. So one of the projects that we have is called Merkle-ized, which is a sort of a Merkleized data store. And this is basically our opcode list for Merkleized. It's 7 opcodes. The bottom 3 are for consensus purposes. So really, the opcode, like, for the application is 4. Like, you can massively reduce the complexity of your application, and this is so much simpler than having an entire EVM. And you can, and like I said earlier, the throughput for proof of stake chains are basically twofold. There's the computational complexity and the network latencies. So if you can reduce those computational complexities, you can get far greater throughput and scalability in your application. And then finally, you can fine tune to optimize for your application. For example, Bitcoin is a UTXO system because UTXOs, quite honestly, are better for payment processors. Payments tend to be a very stateless application. And so UTXOs allow payments to be parallelized much better. But Ethereum is an account model because the account model is better for the general use cases. You can build arbitrary systems on it. But if I want to make an application that's a payment processor, I shouldn't be forced to use the suboptimal model for my application. I'd rather build my application with a UTXO system because it's optimal for my use case. And so essentially what this system allows for is, yes, we have a sharded system just like Ethereum, but it's unlike Ethereum, which is homogenously sharded. This is a heterogeneously sharded ecosystem. You get this diversity that allows everything to work better together. For example, in the internet, we have a common protocol for the web, like HTTP and stuff, but Google's servers are not configured the same way that Facebook servers are, and because they're different applications with different needs. In the same way, it doesn't make sense to have multiple blockchains for different use cases configured in exactly the same way. Yeah, and so what are the two things that I think that the Ethereum really did bring that were really useful? Were one, it made it easier for applications to talk to each other, and two, it made it really easy to write your own application. For the second one is why we have the Cosmos SDK. We make it super easy to write your own dApps. We give you all of the Tendermint, the consensus stuff is done for you, Basecoin is done for you. You just have to write in the plugins, and each plugin is like 2 files of Go. One is an interface, one's the functionality. It's super easy to write your own applications. But for the interoperability side, it's a little bit harder because now that these are on different chains, interoperating these chains needs something new. And this is where the IBC protocol I mentioned earlier comes in. IBC is basically, it's a two-way on-chain light client protocol, basically side chains, but it's designed for proof-of-stake side chains. And what this allows is for applications and smart contracts on different chains to interact with each other. And this is where one of our products called Cosmos Hub comes in, allows for the deep integration of token economies. And this means you can do token transfers across chains. And so a question I often get asked is that the same thing as like interledger or token swaps? And this is very different actually. So if you think about what a token swap is, it's not a DEX or a token swap. If you think what trades and swaps are, it's two things of equal value being traded. I have a certain amount of Bitcoin, you have a certain amount of Ether, we'll trade it if the amount we're trading is valued the same. But this doesn't actually allow value to transfer across chains. It only allows ownership on chains to change. What token transfers will allow you to do is, let's say you have Bitcoin, you could freeze it on the Bitcoin blockchain and withdraw it on the Ethereum blockchain as an ERC20 token called Bitcoin. And so then smart contracts on the Ethereum blockchain can learn to accept this ERC20 token as payment. And so you can start paying for a smart contract, paying for stuff on the Ethereum blockchain with Bitcoin. Tokens are actually moving across chains. And then, back to the benefits. Another one is, I think, sovereignty, right? I think that it doesn't make sense for different applications to be forced to share the same validator set. And this is personally where I think, one of the big differences between Cosmos and Polkadot, is that in Polkadot, it makes it a little bit easier to have deeper integration between systems, but Polkadot requires you to give up your own validator set. If you want to join the Polkadot ecosystem, you have to use their validators. While in Cosmos, you can plug in using your own validator set. So if Ethereum, once it switches to Casper, it can plug directly into Cosmos using its own validators. And this is super cool because it doesn't make sense to force everyone to use the same validator set. Ethereum and Ethereum Classic, I think fundamentally can't have the same validator set. They just have vastly differing philosophies. And they shouldn't share validators, but they should still be allowed to interoperate with each other. And this is what the IBC Cosmos Hub system allows for. And then also you get a way for private chains to interoperate with public chains. Because private chains can keep their own sovereignty but still share data with public chains, they'll be more willing to join into this ecosystem. Another cool thing is that you can, with this sovereignty aspect, you can get actually higher security. So for anyone who doesn't know, the flag on the right is the flag of a micronation called Liberland. It's a sort of a experimental libertarian nation. And I'm kind of working with them a little bit on building blockchain systems for their voting system, land registry, things like that. And what's really cool is that we're trying to build it as its own blockchain, and it makes sense for that blockchain to have its the validators of this chain should be people in the Liberland ecosystem, and because they have political motivations, they have incentives that are greater than just economic alone. So you often hear of the bribing attacker model, where can I, as an attacker, I don't have the majority of the power in the network, but can I bribe people to do what I want them to do, to help me attack? But the thing is, it's harder, and that works if you're dealing with purely economically rational entities, but humans aren't that. Humans have other motivations other than just economics alone. And it will be much harder to try to convince a Liberland validator to screw over that system than it would to be convince an economically rational validator. And so having these sovereign, community-oriented chains allows you to get higher security through social means. And then finally, you can have governance that's controlled by the community. For example, Parity's wallet, when Parity got hacked the second time, all their funds are now frozen, all the funds that were in that wallet are now frozen. And when the DAO happened a year ago, the Ethereum community was much smaller, and a large percentage of it was invested in the DAO. So it was very easy to convince the Ethereum community to hard fork. It wasn't even that easy. There's still, obviously, Ethereum Classic exists. But it was relatively easier to convince the entire community to hard fork to save the investors of the DAO. But now that the Ethereum community is much, much bigger, it's going to be a very hard uphill battle for the Polkadot team and other people that were affected by the hack to convince the Ethereum community to hard fork to save their funds. But if they were actually on their own blockchain, they'd only have to convince the people in their community to hard fork and save them. And that's a much easier thing to do. And so having these community-specific chains allows governance and fixing of bugs to be handled and only have to be approved by that community, not by this larger global community. And then on the last thing is, you can get sovereignty, but you can also choose to take pooled security. So this is kind of like a balancing act that you have to decide between. Instead of showing up with your own validators, you can actually ask the Cosmos Hub validators to basically for them to validate your chain. And this is really cool because that means everyone who does this is sharing their security, because if the Cosmos Hub validators do something malicious on your chain, they get slashed on your chain, but also the Cosmos Hub chain and all the other chains that they're validating. So you get the economic security of all the chains that are being worked on to get validated together. And you can think of this almost as like merge mining, but in a proof of stake context. So what are some of the implications of this Internet of Blockchains now that we have? One thing is that we'll have much more interoperating functionality. We have all these different systems, all of which have different use cases. And all these features are kind of isolated to each system. But what if we can actually use the privacy benefits of Zcash with Bitcoin and using the smart contracts of Ethereum? Bitcoin is designed primarily as a payment processor, while Ethereum's more of a smart contracting application system. So what if we could get this Bitcoin transfers through Ethereum smart contracts? You can leverage the benefits of both systems to interoperate with each other without actually having to adopt all of the features of the other person. So now Bitcoin doesn't actually have to implement smart contracts. It can use the smart contracts on Ethereum. You also get these, you can get ecosystems that are based around cross-chain tokens. So let's say you have Storage, right? You can actually have a Storage contract on Ethereum, Tezos, and Rootstock all at the same time. And basically, it's the same token on all of them. So let's say you're trying to get something through on Ethereum, but there's just too much backlog. You can move your token over to Tezos and use it there. And basically, this same token can be used across many systems. And it might also have this effect, which I'm personally really hoping for, which is I'm sort of a Bitcoin maximalist when it comes to the currency. I like Bitcoin. I think Bitcoin is the thing that has the most, it's the only thing anywhere close to mainstream adoption. And so I think I really want to help push that. But, Bitcoin is really stifled by its protocol, and I'm not a fan of the protocol. But if we can allow Bitcoin's blockchain to basically become a proof of work mint, where it's just minting Bitcoin, and as soon as it's minted, it moves off into other chains to be used for different functionalities and for scalability purposes. This is a really cool system. So, I don't know, this is a cool question. Will an Internet of Blockchains basically make Bitcoin or maybe Ether or a stable coin perhaps as the currency for blockchains and used across many chains? This is something that's in the future, in the works, but we can also get smart contract calls across chains. So let's say you have an insurance contract going on in a Cosmos SDK chain. You can go ahead and grab some identity information from the Tezos chain. You can grab the insurance information from the chain.com chain, and then you can do the payment settlement on the Ethermint chain, and then it sends everything back to the Cosmos SDK chain. So you can like split your functionality across different chains and have them all interoperate with each other as well. And then you also get the private chains that can help out as well. So, you know, maybe all that insurance information, you don't actually want it on a public chain. What you can have, like Ethereum, still talk to maybe a Hyperledger chain that has a lot of private information on it. And this is really cool because private chains can then basically act as oracles to to an entire blockchain ecosystem. I was just talking to the people back there working on PO8 network, which is basically doing exactly that, allowing proof of authority chains to act as oracles for certain things to public systems. And then one of the hottest things right now is decentralized exchanges, right? So this chart is kind of old right now. You can definitely tell that by the Bitcoin Cash price. But so this is from about a month ago or so. But what I want to point out here is that, you know, if you're building the most popular decentralized exchange right now is EtherDelta. It actually makes up like close to 30 to 40% of the Ethereum throughput, which is a bit crazy to me. But the problem with EtherDelta is it's only limited to Ethereum ERC20 tokens. And so let's just go ahead and look through CoinMarketCap for like what can EtherDelta actually trade. So right here in the top 10 on CoinMarketCap, there's literally 0 ERC20 tokens. Let's keep looking. Okay, we finally see our first ERC20 token at number 13 with Omis Go. But the thing with Omis Go actually is it did an ERC20 token as part of its ICO, but in the long run, it's actually planning on switching to its own blockchain. Happens to be built on Cosmos SDK, which is cool, but you know, it's not planning on staying as an ERC20 token. So let's look for our first real ERC20 token. We finally find it at number 28 with Augur, which is actually designed to be an ERC20 token on the Ethereum ecosystem. But the thing is that if you're building a decentralized exchange that's focused on the Ethereum ecosystem, you're basically missing out on like the majority of the value in the system. The first 27 coins on CoinMarketCap are just not covered within the Ethereum ecosystem. And so if you're building an ERC20 or a decentralized exchange, you should build it as a cross-chain exchange. So Kyber Network is building their system on Ethermint, while Omis Go is building it on Cosmos SDK. And so this is really cool because now these decentralized exchanges can be done with many different tokens across many different chains. And then the last thing to ponder is another thing that might happen is we get this sort of geographic sharding, where you know, I said application layer sharding is one of the most logical ways to shard because it limits the throughput. But like I said, in proof of stake, the two things that affect throughput the most is the computational complexity and the network latencies. So if you can have all your validators closer together geographically, you can greatly reduce the network latencies. So this might lead to a system where we get a lot of geographic sharding. Maybe we'll have a Cosmos North America hub talking to a Cosmos China hub, talking to a Cosmos Africa hub, and then all these hubs maybe when they need to deal with like inter-hub transfer, then they go to a higher hub, and you get this very federated model, but that's like based off geography. And the question is, I don't know, is this a good thing? Is this a bad thing? Like, this system was designed to be a global system. Is having this sort of geographic sharding making it more fragile or not? This is an open question to ponder, I think. But yeah, so thank you all for listening. This is Let's Go Cosmos. Yeah, I can take any questions if anyone has any. Yes.
So we're building, I'm glad you touched on geographic sharding, so we're building like a decentralized like mapping platform, and mapping is really like an ideal use case for geographic sharding, but we were looking at EOS as like our blockchain. I guess can you like briefly in broad strokes touch like your the Tendermint consensus versus like the DPoS? Like,
sure.
Like what are some big advantages?
Yeah, so if you actually go on our blog, we actually have like a really long blog post specifically about that. But a couple of things I can just touch on is so DPoS was a very old attempt at proof of stake, and it's not okay. There's a bunch of issues with it. For one, it doesn't have any sort of slashing or anything, so there's no penalties for validators doing anything malicious at all. And so, if you don't have these sort of penalties, validators really have nothing at it. EOS doesn't solve the nothing at stake problem, basically. And that's like right there is one of the biggest issues. Some other issues with it is, it's heavily reliant on a synchronous system, while Tendermint is safe in asynchrony, which is another great benefit. EOS blocks your time to find. So each block is 3 seconds, but the block and they have 21 assuming there's not enough details right now, but assuming it's somewhat similar to BitShares, you have 21 validators. And so it's actually going to be the block that's 14 deep that's being finalized. And so if you have 3 seconds per block, that's going to be like 42 seconds until finalization. While the cool thing about Tendermint is every single block is being finalized. And so you can get, block times will probably be around somewhere in the ballpark of 1 to 3 seconds. So you'll get your finality far faster than DPoS would allow for. And the reason DPoS needs these 3-second block times is because of its synchrony assumption. If you have an basically in a synchronous system, you need to make sure your block times are far greater than network latencies. But in an asynchronous system, you can actually kind of like try to, block times can't be shorter than network latencies, but you can try to like push the limit and make them like as long as network latencies. And so you can get this much smaller block times as well. Vlad's Casper is sort of, DPoS is an attempt of proof of stake on Nakamoto consensus, and it has all these issues. Vlad's Casper is sort of like an attempt to solve all these issues. It's more of an asynchronous system and still works in Nakamoto consensus. So, as opposed to DPoS, Vlad's Casper I think is definitely much more interesting. Yep. Anyone else? Yes.
This is more of a general question, but I don't often see scaling solutions classified into vertical versus horizontal. So can you kind of go over maybe the trade-offs they make in terms of like security and decentralization if they do make those trade-offs there?
Sure. So one thing is vertical and horizontal, like they're just like broad categories, and there's like, especially on the vertical side, there's so many different types of vertical scalability. But I would say one of the biggest things is that what you should do is try to maximize vertical scalability, and then once you reach your limit on vertical scalability, you also use horizontal scalability. I don't think there's really any trade-off. I don't think there's a trade-off that's really being made here. Jay's raising his hand, so maybe he has another opinion on that.
Yeah, I just had a thought that if you have a blockchain that is limited in vertical scalability so that you can sync it on a laptop, then maybe it'll just be decentralized.
Yeah. Yeah, so I mean, like, if you don't want, like, gigabyte blocks, right, which is really hard for people to sync on their Raspberry Pi, right, you maybe want to put an artificial cap on the vertical scalability, and then to have more scalability beyond that, then you use the horizontal scalability. Horizontal scalability, yeah. Yes.
So I'm wondering, with all these moving parts, I wonder how you test and ensure that the code you're doing is fault-free in a sense.
Jay, do you want to answer that one?
Sure. It's a process. We're improving that. We have the integration system tests. For example, where like the EFT research was really formalized the algorithm. This is nice to use formal verification building.
We had like a report by Jepson, which is like a distributed systems research lab, and so they released a report on testing Tendermint consensus across different faults that they pushed onto the system. And so you can go ahead and read that report about the Tendermint core testing.
What has me sort of worried is when you have all these different systems interacting in ways that are not obvious. That's what's worrying me. I'm not so worried about the correctness of the core protocol because that's relatively well understood stuff, right?
Right.
So,
Right. So, yeah, I mean that's definitely something that is it kind of punts the problem onto the application developers to make sure that their stuff is being done correctly. But as Jay said, it would be nice if we had formal verification systems. So right now, Cosmos SDK, the plugins are written in Go, but one thing that we're thinking of doing is having it so we can build wrappers around other languages. So basically, then you can write your plugins in Rust or even functional languages, and so that way, if you write Haskell code, then you can actually formally verify it, which would be cool. But yeah, I would say that any application that's this is true in any system, even with Ethereum, where if your application is interacting with a specific chain, you want to make sure that that chain is properly audited and everything. Yeah. Yes.
Yeah, the initial blockchain system, as far as I understood, was perfectly decentralized. And here with these applications, you're centralizing, putting some specific applications to a certain server, a certain network that is separate from the rest. What are the consequences in terms of reliability, safety of your applications? Have you tried to quantify that in some applications?
So one thing is, it's not centralizing the applications, it's just giving it to it's still a decentralized system, but it's just the community that's running it is smaller. It's the people who are actually invested in that
system. If it's smaller, it's less safe.
Right. Yes, it's less safe in the way that maybe there's less validators running the system. But that's why we have the whole system of, like I said, the pooled security, where different chains can still pool their security into one validator set. And this still has scalability benefits, because you might think oh, if it's just one validator set that's running it, what's wrong with it? Why not just run all of that in one chain? But the thing is, running it, so if you run things in one chain, that basically means you're trying to totally order all the transactions in that chain. While if you're running it on different chains, you can actually parallelize all of these tasks. So one validator might be having a server rack, and for every chain that they're validating, they have it in a different server. So it's all these chains are running in parallel rather than in sequence. So you still get the heavy scalability benefits. And then you can also start doing stuff like what Polkadot plans to do with sort of this cryptographic sortition, where you take your large validator set, you put it in, you choose small subsets and tell them, you guys validate this chain, you guys validate this one, and then you have you have to do fraud proofs and stuff, but that gets very complicated. For now, we're focusing just on a global validator set, but still allowing them to run it in parallel. Yes.
So if I understand correctly, your application engine restricts applications to non-Turing completeness.
No.
No? Then where does the non-Turing completeness come in then?
So for example, Ethermint is an application that we have on the system, and Ethermint, the EVM is a Turing-complete VM. And so where the non-Turing completeness comes in is you can write your application code as whatever you want. And the thing is, you're writing your application in a programming language. Let's say it's Go. Go is a Turing-complete language. The application functionality, you can write whatever you want. It's Turing-complete. But the question is, once the chain is deployed, the functionality on top of it is that Turing-complete. And so the EVM the application is a Turing-complete VM. But meanwhile, Bitcoin, the application itself, is not a Turing-complete application. It doesn't have a Turing-complete VM on top. And so my claim, what I'm saying is, that you don't want to build your application here on top of a Turing-complete VM. What you want to build is your application right here, so you can cut out that common application that may not be designed for your use cases.
No, I'm totally on board with that because
Yeah.
if you restrict to non-Turing completeness, you open the door to static analysis, and now
Right.
you can do some real proofs of security and proofs of, this application actually does what it claims to do and nothing more.
Sure. So the writing of the application doesn't restrict to non-Turing completeness, right? This can be anything you want, as long as it's a deterministic state machine. But yeah, once you have your VM, you can even write smart contracting VMs that are not Turing complete as well. So like Tendermint basically is a non-Turing complete VM. It's kind of an extension of they forked from the Bitcoin Bitcoin code base like years ago, but they added a lot of cool functionality, and they have a programming language called Ivy, which is like I think if you're building financial smart contracts, like use Ivy. It is so easy to write most financial use cases on that.
What's that project?
So it's chain.com. They used to build like permission chains, but they have their VM. They have a smart contract language called Ivy, which compiles down to their VM. But what's really cool is that they're working on is they also have a version that compiles to Bitcoin script, which is super cool. But it has to be a subset. But yeah. Yes.
In terms of application, would it be feasible to migrate traditional hybrid or cloud-based enterprises like finance, Oracle, SAP, or work into your blockchain?
Yeah.
And so what is the what do you call it, advantage over the traditional?
Sure. One thing that has to be kept in mind is that you have to make sure that whatever you're migrating over is deterministic, because if it's not, that can cause bugs and cause the entire blockchain to halt. But if you have a deterministic system, all you have to do is make sure it also complies with the ABCI interface, and then it can be plugged into the system. A few months ago, Oracle decided to try to file a patent using Tendermint Core software, so it seems that they're trying to do exactly that. Yes?
So I actually want to follow up on this question about like interoperability and security. So Tether just announced that they got like a $30 million hack.
Really? Okay.
Yeah, in the past
Finally.
couple hours. But they're
Hack.
Yeah, apparently they got stolen out of the treasury wallet. And apparently their response is to go through governance to essentially tell the validators to not deal with those funds. So if we look at like the interoperability that the Tendermint ABCI kind of provides across the applications, like how would that fall into like a model like that where they're using governance to deal with situations?
Right. So how the Cosmos Hub would work is each token would be given what's a home token or a home chain. And so let's say in the case of like Tether right here, basically is a private chain, any tokens that are transferred onto other systems, basically what the Cosmos Hub does is it acts as a way to prevent chains from double spending other chains. That's kind of the purpose. And so what the hub will do is designate the Tether chain as the home of the Tether token. And so the Tether chain has exclusive rights to mint tokens on the hub. And so that way it's actually okay if the Tether chain's governance says we want to mint new tokens or reverse something that happened. We have the control, and the hub will listen to our jurisdiction on that token. Any other questions? Oh, yes.
I'm working with a company that's building a smart city in Brazil for 30,000 people, and we were studying a way to introduce a currency for this community that can be used within the community for any kind of exchange. But there were so many problems with using Ethereum or using other things, while my impression is that using Cosmos is possible to create a system and make in a way that you can use you have all the nodes that are only focused on that community.
Mhm.
So you confirm that this is something is possible.
Yeah. Ethan, who's the other like co-founder of Tendermint, along with Jay, he's like super into the idea of like local currencies and stuff. And this is like one of his like favorite use cases of Tendermint Cosmos is this like highly sharded, geographically sharded federated and geographically sharded ecosystem that allows for these like sort of local currencies. Yeah. And I'm like a huge fan of this as well. I really like the idea of using the Bancor protocol. Not really like their smart contracts and stuff because I don't like how they implemented it, especially if they don't need a token. But like using their protocol in order you can make these local currencies that are sort of backed by another currency, but like partially backed. So you can like create a local currency that has a partial reserve of Bitcoin, for example. And I think that's a really cool idea. Yes.
This is all foreign language to me.
Sorry.
We just have a few Bitcoin and we wanted to learn.
Mm-hmm.
But I'm kind of getting from this that it's not like it's either or, like Bitcoin or one that will win or what lead, but that they might actually overlap or share the platform together is what I'm getting kind of.
Yep, that's kind of what one of the goals of Cosmos is. It's like, we don't buy into this like one chain to rule them all philosophy. It's like I said, you want to be able to use the benefits of every system and like use them. Each system has its own benefits, and you can use all these benefits together. Yep. Anything else?
Yeah, I just when you were talking about Turing-completeness, you had a reduced instruction set slide, and I just kind of wanted to look at that once again. And
Sure.
you just sort of kind of repeat your comments, and it's kind of from back here. It kind of looks like a REST API plus some governance. That's kind of what it looks like.
I mean, so this opcode set is specifically for the Merkle eyes. It's like Merkle and then eyes.
Oh, Merkle eyes.
Yeah.
I see.
And this application is literally just a key value store. It's a Merkleized like key value store running on Tendermint consensus. And so you can use this for very basic applications such as like Namecoin, for example.
I see.
Or something like that. And so that's why this opcode set is like 4 things.
Right, I see.
Yeah. Nice. Yeah. You can define your interface to your system to your application however you want.
Okay.
Yep. Is there anything else? Anyone else? Any more questions? Cool. Okay.